The objective of this project is to improve processes used in the bifold door manufacturing cell at JELD-1's facility. The goal is to increase throughput in order to meet customer demand and to optimize the cell for one-piece flow.
Specifications and deliverables within this project included compliance with COVID-19 protocols and electrical protocols. In addition, performance specs included a takt of 4 doors a minute, as well as maintaining a lifting index below 1.0 to ensure operator safety, as well as maintaining less than or equal to the number of workers they were currently using in the cell, and making sure the defect per million opportunities was that of the JELD-1 standard. Deliverables included eventual implementation, as well as analyses through time studies, ergonomic analysis to relate back to the lifting index, as well as provide future recommendations to JELD-1 about staffing as well as cell layout.
Our initial expected expenses for this project were over $3,600. By using scrap materials and reducing the amount of travel, we were able to reduce the budget down to around $3,000.
The improvement to the paint machine loading area includes a design made of 6000 grade aluminum alloy that will reduce material handling and operator usage. This design will allow the operator to stack 2 doors on the conveyor at a time, compared to 1 door at a time, which is the current rate. The height of the design will be adjustable to accommodate for different door widths and will have a protective material where the doors will contact the design to ensure a high-quality product.
The goal of the stacking design is to reduce material handling and the time it takes for the operator to stack the doors and move them to the hinging machine. The table shown was made to stack the doors automatically compared to having the operator stack them. The design works by having the first half of the door slide onto the table and having the second half slide on top of the first one with the help of an automatic conveyor. The table itself is made from aluminum, which means it's lightweight, and the table also has a UHMW sheet to reduce coefficient of friction. There are bolt holes on the bottom of the feet to adjust the height as needed. There's also a sensor mount, which is adjustable with a slot cut onto the side of the table to make room for the sensor laser.
Currently, there is one sensor located at the end of the conveyor. When the sensor detects a door, the conveyor stops. We will be adding an additional sensor on the stacking table design. The current sensor and the additional sensor will be wired together to operate as an AND gate. When both sensors detect doors, the conveyor will stop, as simulated with the yellow LED in the figures above. This will allow 2 doors to reach the stacking table before the conveyor stops.
We were able to successfully incorporate our designs into the bifold flow cell and performed a time study, quality study, and ergonomic analysis to determine the impact of our designs.
While not changing the number of operators in the cell, cycle times drastically decreased while throughput saw an 18% increase, as well as the lifting index values for both of the addressed portions of the cell were cut in half.